Now that we are experts at solving one-step equations, so equations that just have one operation, like they just have addition, so we use subtraction to solve, or maybe there was just division, so we use multiplication to solve, this lesson is about learning how to solve two-step equations. And we're going to begin with this vocabulary review. You've seen it on two different videos before, but keeping in mind that inverse operations are operations that undo each other. And on your note page, you're going to want to fill in that addition undoes subtraction and multiplication undoes division. We also review what a balance line is. And a balance line is a line that we draw through the equal sign of an equation, and it reminds us of something really important that we've written in other notes, but you're going to write it again because it's just that important. What I do to one side, I must do to the other. So if I add 2 on the left, I have to add 2 on the right. If I multiply by 5 on the right, I have to multiply by 5 on the left. And that's what the balance line reminds me. So the first way I'm going to model an equation is using something called algebra tiles. We have sets of these in class that we'll be using, little plastic squares and rectangles that are different color, and they symbolize x if it's a green rectangle, and the red rectangle that's the same size is negative x. And then there's a little square that represents 1 and a little red square that represents negative 1. So if I use algebra tiles to model an equation like the one that you see at the top of your page now, negative 3x, that means I would need 3 of these negative x's. Now I have negative 3x. And minus 4 means I would need 4 of these little red tiles. Then I can see I have my equal sign, which in this diagram, that's where my balance line would go. That's why you see the 2 purple squares, that one side is the same as the other. I'm going to need 10. Oops, let me see if I can do this a little bit quicker. I'm going to need 10 of these red ones, and I tried to have that already done. So here's what my equation looks like. Negative 3x minus 4 equals negative 10. So you'll notice over here on the left that we have a definition. I can tell it's a definition because it's got this little star next to it. A zero pair is a pair of numbers that add together to form 0. That's also called the additive inverse. For example, 4 plus negative 4 is 0. Negative 2 plus 2 is 0. So we can call them opposites, we can call them the additive inverse, or we can call them a zero pair. So here's what a zero pair looks like using algebra tiles. I'm going to bring a positive 1 over, and another positive 1 over, and another positive 1 over, and another 1. I brought over a total of 4 yellow number 1, okay? So I'm going to need a total of 4 more on the other side, because I remember what I do on one side, I have to do to the other. So since I added 4 yellow tiles on the left, I also had to add 4 yellow tiles on the right. And what is going to happen is these two pieces join together and they become 0, so they go away. And these two join together, 1 and negative 1 are 0, they go away. And this 1 and a negative 1, they join together, go away. And these join together and go away. Now the same thing is going to happen on the other side, that 1 and negative 1, those two things together become 0. And here's another 0 pair, and another 0 pair, and one final 0 pair, where a negative 1 and a 1 join together to make 0. So now here's what's left on my equation. I have negative 3x equals, and if I count over here, it looks like I have 1, 2, 3, 4, 5, 6. It equals -6. So this last part, I like to pretend that we are playing a game. You play soccer or basketball, it doesn't really matter. But I have 3, team captains. There's 1, there's 2, and there's 3. I have 3 team captains. And they get to pick 1 player at a time out of these 6 players until everybody is gone. So the first captain chooses this, second captain chooses this, third captain chooses this, first captain, second captain, third captain. So what I can see now is this. I can see that -x equals -2. And so the final step there, because we're always trying to isolate the x, we're always trying to get the x by itself, we need to go one step further and we need to know what a positive x equals. And we can think about it as negative being the opposite. So what's the opposite of -x? Positive x. So I already have that. And what's the opposite of -2? +2. So the answer to this equation is x equals 2. Positive x equals +2. And I really like the algebra tiles. It's a visual way to see what is happening when we're solving equations. But you can see how long this took me, and this was an equation that had fairly small numbers. It would not make sense to use algebra tiles if I had fractions within my problem, or if I had decimals, or let's say that instead of this number being -10, what if it was -1000? I wouldn't want to have to drag 1,000 of these little tiles over. So we're going to learn how to solve problems in a different way. And here's something you'll need to get used to hearing, because you'll hear this for the rest of the year when we're solving equations. I'll first say that you need to draw a balance line. And then I'll ask you, what is the variable? And then I'll ask you to circle the variable with its coefficient. So we have to remember the word coefficient. We remember the prefix co means with. So it's the number with the variable. Then I'll ask you, what is with the variable that we need to undo first? And we always undo addition and subtraction first. If there's addition and subtraction, that's where we're going to start. We're going to get rid of addition and subtraction first. And there's that famous line you'll hear me say in class, what I do to one side, you do to the other. And finally, how do I isolate the variable? How do I get the variable by itself? This one final step, and it will be with multiplication or division. The best thing about these videos, again, is that you can pause at any time to copy down those steps. On your note page, you have this table that's going to help you organize your work. This is, first step is to write the equation, -4 equals 9x plus 23. I'm going to ask you to draw a balance line all the way down this paper. And that's going to help me remember that what I do to one side, I do to the other. So now that I have a balance line, my question is, what is the variable? The variable is x. I'd like you to circle x with its coefficient, which in this case happens to be 9. So now that I have that circled, I leave that till the end, and I have to deal with this plus 23 over here. So I need to use inverse operations that will undo a plus 23. The inverse of plus 23 is minus 23. What I do on one side, I do to the other. And I'd like you to please show in your notes that this becomes 0. This is a 0 pair. That's what makes it go away. Now I get to simplify in this box. I see that these have the same sign. They're both negative, so I add them. And I keep the sign. And I bring this 9x right down. Now I need to use inverse operations to undo the multiplication and division. Well, this actually says 9 times x. There's an invisible multiplication sign there that you guys don't see because I'm lazy and I don't write it, but you know that that is times by 9. And the opposite of times by 9 is divide by 9. What I do on one side, I do to the other. And what is 9 divided by 9? It is the whole number 1. So please write a big 1 there. 9 over 9 is 1x, but you know that I won't write 1x. I'm lazy. I'll just write that x by itself. And negative 27 divided by 9 is negative 3. So my solution, I believe that x is negative 3. And in this last box, I have room to check. And here's what checking will look like. Negative 4 equals 9 double plus 23. And what do you think I'll fill in that bubble? Well, I'm going to try this negative 3 that I just found was my answer. And now I'm going to see if this actually works out. This says 9 times negative 3. Well, that's negative 27. And do these have same signs or different? They're different, so I subtract. 27 take away 23 is 4, and it is negative because the 27 was larger, which I can now see that this was the correct solution. Negative 4 does indeed equal negative 4. I know that I have solved this problem correctly. Here's another example. This one's going to be a little bit special because of the coefficient that is with the variable. 124 subtract 8g equals 36. First, I will ask you to draw a balance line. Then I'm going to ask, what is the variable? The variable is g. I would like you to circle the g with its coefficient, and its coefficient, please be careful, the coefficient is negative 8. So you need to circle the entire coefficient, negative 8. Now, what is with the variable that needs to go away first? Well, I see 124 that I need to get rid of. And I get rid of a positive 124 by subtracting 124. And what I do on one side, I do to the other. Please show that this becomes 0. This is a 0 pair. And I'm going to bring straight down negative 8g equals. These have different signs, so I will subtract. I need to do 124 take away 36. I know I'm going to have to borrow. And when I do that, I'll find out that the answer to 124 take away 36 is negative 88. Negative 88. Now, my final step is to undo the multiplication and division. And I know that there is multiplication hiding in there. It's actually negative 8 times g. So the opposite of times by negative 8, or the inverse of times by negative 8, is divide by negative 8. What I do on one side, I do to the other. And negative 8 divided by negative 8 is the whole number 1. So now what I am left with is 1g. You know I'm just going to write g. And negative 88 divided by negative 8 is positive 11. So I think the answer to this problem is 11, but you have one more step to do, which is to check. And checking will look like this. 124 minus 8 bubble equals 36. And what are you going to fill in that bubble? Well, we're going to fill in 11 because we think g is 11. I'd like you to finish this checking tonight, have it complete on your notes tomorrow. And here's one more problem. I'm going to begin by writing the equation. K over 5 plus 19 equals negative 31. Our first step here is always to draw the balance line. And then what is the variable? In this case, the variable is k. I'd like you to circle it with its coefficient, and its coefficient there is the divided by 5. It's kind of different than the first two we've seen, but that is the coefficient. And the first thing I need to undo is that plus 19. I undo plus 19 by doing minus 19. And what I do on one side, I must do to the other. Please make sure that you're showing this becomes 0 because it is a 0 pair. And then I'm just going to bring straight down k over 5. That's all that's left there. These have same signs, so I will add them, which gives me 50, and it is negative. Same signs, so we add and keep the sign. And now I need to do the opposite, and I can guarantee that if you were taking a multiple choice test, the first answer that they would give you would be 10, and they want you to fall for that because you see a 50, you see a 5, and you think 10. But I need to think about what this actually means. This line means divide by 5. What's the opposite of divide by 5? Multiply by 5. What I do on one side, I do to the other. So I need to multiply both sides by 5. 5 over 5, yeah, that's still a big, let me use a different color. That's a big number, 1. I've got 1k, you know I'm just going to write k. And I need to multiply negative 50 times 5, which is negative 250. That actually goes one step lower because of how I put my multiplication in there. And I would like you tonight to do the check part on this equation so that you are checking to see if negative 250 is indeed the solution.